Hey everybody, welcome to Math with Ace. We are going to be talking about linear equations today, specifically what makes an equation linear, what they look like, and how to work with them. So, very basic overview, an equation rather than expression has an equal sign. So, in a linear equation, you need an equal sign. And a lot of times when we talk about lines, students will know y equals mx plus b. That is the statement that is something we kind of get ingrained in our memory. We memorize it. And knowing the components help us understand this expression or this equation here. Now, it's important to note we have two variables. We have an x and we have a y. X is our independent variable. And y is our dependent variable. Y depends on x. Whatever the value of x is helps us determine what the y variable is. So a lot of times we will plug in some value for the independent variable or the input, and we will get our output. You will see domain associated with x, you will see range associated with y, but x is our input and typically y is our output. The thing about x and y to note is that they are to a single power. They are not raised to a power of 2 or higher or some fraction, some number that is not 1. So it's as if there's an imaginary 1 here, which means y to the first or x to the first. In a linear equation, both x and y must be to the first power, and you don't need any other variables that are like z or something else. So x and y need to be to the first power. And they need to be the only variables. Well, you might be thinking, well, you have four variables up there. You have m, you have b, you have y, you have x. M and b are constants these are placeholders for actual numbers depending on the situation. And they actually hold a special relationship. M here represents our slope. It is the number next to x. So in this situation, m is our slope. So whatever constant is in front of x is the slope because x changes based on that value. And remember, slope, a lot of times we say rise over run. Slope is a rate of change, and it tells you how much you are increasing or decreasing as you go along the x-axis. So if you're on a mountain and you're skiing, you're going up the lift versus down the lift. How steep is that mountain? What is the rate of change in feet for every 100 feet? If you go drive and you see these signs on the side of the road that will have a picture of a truck on a hill and it'll say like 6%, what that means is for every 6 feet, you're decreasing 100 feet. So it's telling you that it's a steeper incline. The B here represents our y-intercept. The number that is by itself, the constant value by itself, is the intercept value. Now we're going to take this and flip it on its head when we're talking about statistics because we're not using M and B anymore. We're using B and A. And B is no longer the intercept, it's actually the slope. So you have A plus BX. And so it's important to pay attention to the fact that the slope is always the number with X and the intercept is always the number without the X because it's when you have 0x. So for statistics, we have y equals A plus BX. So again, y is the dependent variable, x is the independent variable, a is the y-intercept, and b is the slope. So that A value tells us where we start on the y-axis. So whenever you're looking at a graph, you have X and Y. X is the axis that is horizontal, and Y is the vertical axis. So when you're talking about rise over run, that means that you're talking about Y over X. So slope is the change in Y over the change in X, and that delta represents change. It's a Greek letter that's used in sciences to represent change. When you have a linear equation, your graph needs to make a line. You can't connect the dots and say this is a linear equation. It needs to not be a curve, it needs to be a straight line. So you can have a linear equation that is straight up and down, that is side to side, or positive or negative. May not be a function if it's straight up and down, but those are the options for a linear equation. So think about it, a line, let's say this blue line, pretend that's a line, and I take that and I just rotate it 360 degrees. So it's going to go through all of the different options here. Now, when you're trying to figure out whether a graph is positive or negative, or has zero slope or undefined slope, you can look at start from left to right. So when we read in the English language, we go from left to right. So start from left to right. If your graph goes up from left to right, it's a positive slope. And what that means is positive values are associated with positive values, negative values are associated with negative values if you're talking about in the first quadrant. This is a positive slope. And remember, I'm saying going from left to right. If you go from right to left, it's going down. So always think about it from left to right. A negative slope would be one that goes down and to the right. So this is negative. A horizontal slope or zero slope is one that is straight across and it's parallel to the x-axis. All three of those are functions, but when you draw a vertical line, this is no longer a function because it is defined as x equals. This has undefined slope. Now, if we're talking about in statistics, we don't necessarily care about whether you have an undefined slope or not. We're not really going to have situations like that with linear regression. You're either going to have a positive slope, a negative slope, or zero slope. And zero slope actually means that there's no relationship because your y does not change for your x. So the key things about a linear equation and how do you determine whether something's a linear equation is that you have x and y's only, and to the first power. You have an equal sign, and then you have your constant values. Not all equations are going to have a or bx. You could see equations in the form y equals bx, where there is no a, which means it starts at 0. Or you could say y equals a, which means there is no slope, and it goes through at whatever, it's a straight line in that situation. Okay, so this has a 0 y-intercept, and then a means that there is no change in slope, it's a zero slope. Now, typically, we will plug in values for x and get out input for y. That's something to think about. We'll making predictions based on x and y's. The other thing you want to consider is that ordered pairs are always written x, comma, y. So we always put the x term first and y second. In stats, we will be focusing on the first quadrant. We won't be going in the whole 4 quadrants of the Cartesian plane. We're just going to be focusing on that first quadrant because our numbers, we're going to be dealing with real world situations, typically where we have positive on our axes. Okay, so this is the basics of linear equations. Thanks for watching.